So hello guys. So today we will see the problem, the Leecode daily problem, which is problem number 1975. Okay. So what our problem says that you are given the n by n integer matrix. You can do the following operations any number of times. So what the type of operation we can say it can choose any two adjacent elements of the matrix and multiply each of them by -1. Okay, so we can multiply two adjacent elements with -1. Okay, so we can do them negative if they are positive, or if they are negative already, so we can them at a is the positive. Okay, so two adjacent elements are considered as adjacent if and only if they share the border. So the border in the way means just like when we have this type of matrix. Okay, so I am drawing here the matrix. Here is a 1 2 3 4 -1 -2 3 4 5. Okay, so in this type we can consider this as a adjacent, this as a adjacent pair. Okay, so the next as a this will not be considered as a adjacent pair, this will not be considered as a adjacent pair. Okay, so now we can consider this as a adjacent, and now we can travel this negative sign towards any of the number. How? So just like we have made this pair as an adjacent pair and make them and change their sign by multiplying it by -1. Okay, -1. So their sign will be shifted to this. Okay, so this sign will be shifted to this will be positive. Okay, after that, after this 2 will be selected, just like this 2. Okay, so after this 2 will be selected, this will be positive, this will be also be positive. Okay, both of them will be positive. Okay, so from that we can say that if we have the even number of negative signs, negatives. Okay, negatives, even number of negatives if we have, so we can get all the we can negate all the negatives from the matrix. Okay, from the overall matrix, so we can negate all the negatives from, then we can negate all the, okay, we can negate, okay, we can negate all negatives, and if the second, this will be the first condition, and sorry, and the second will be when the odd number of negatives will be there, odd number of negatives. So we will travel it, then we will travel it to, then we will shift that negative. Okay, then we will shift that negative to the we have to maximize the score. So so do it the focus here that we have to maximize the sum of the matrix elements. Okay, so to maximize it, we have to travel that negative sign to the minimum element, Okay, so I will discuss it that how we will travel it to. Okay, so we will shift that negative to the minimum one, main element. Okay, main element of the matrix, Okay, So we will discuss now how we will travel this negative sign if we have the odd number of negatives. Okay, so okay, let's take this example as a three negatives. Okay, this is a one negative, this one negative, this one. Okay. Okay, we can take that this negatives is not here. Okay, so we will try to take the negatives as far away from them. Okay, it's 3, it's a 3 and it's a 4. Okay, now this negatives, okay, this 4 and 2, these negatives are not adjacent to them. Okay, so how we will cancel out them? Okay, so we can cancel out them by taking this negative sign to shifting to this one. How? Now how we will do this? Okay, we will do this by multiplying by taking this pair, sorry, by taking this pair we can change their signs. Okay, so what we will get, this will be positive and this will be negative. Okay, now we can take these two pairs and we will change this sign to positive, this also to positive. So we will get the sign as a, sorry, this is a 2 and this, okay, this, so all will be positive. But when there is only one negative sign, so we will have to we will have to remain it. Okay, so that negative sign, that single negative sign cannot be cancelled out, so that's why we have to travel this negative sign to the smallest one. Now from the smallest from the overall matrix there is only one. Okay, and this one and this one. Okay, this is the smallest, minimum from overall matrix. Okay, so now if we have the condition that we have the odd number of negatives and we have the negative on 4. Okay, now how we will traveling it to the 1. Okay, so how we will travel it? We will just multiply this pair, okay, with -1. So this minus will be plus and this plus will be minus. Okay, after that we will take this pair, so this minus will be plus, this plus will be minus. Okay, now this plus will be minus and this will be plus. Okay, after this we will take this pair. So when we have the minimum from that matrix is the 1 we have, which is the minimum. Okay, so we will take this pair and make this as a negative and this as a positive. So we have get that the minimum as a negative. So now when we will sum this one, so we will get the maximum result. Okay, so we will now get maximum result here. Okay, so this is our approach, and let's see the code how we will do this. Okay, so now in this we have just taken the answer is equal to 0. So answer means the maximum score, we can say max score, or we can say as a score. Okay, score. Okay, we can say as a score also. Okay, minimum element int maximum. So we have to find out the minimum element, figure out the minimum element. If we get and this will be only possible, this will be only usable when we have the odd number of negatives. Okay, so now for this we will also having to count the negatives also. Okay. So we will have to count the negatives, how many number of negatives we have present there. Okay. Then we will traverse in the for loop and sorry. Now when we have the j is less than 0, so count negative will be plus plus. Okay. After that, answer plus equal to absolute of j. So we will count all of them as a absolute of the j, means their absolute value will be added in the answer. Then we will so we are in the for loop, we are traversing their address values. Okay, so we are not making their copy, so we are making their address values. So there is a ampersand which can reduce our by copy by reference. Okay, call by reference. So we doesn't make the copy here and here also. And if we doesn't apply the that and operator, so this is the address variable, we can say. Okay. This is the address, how we can take the address of the matrix, okay, matrix array. Okay, so if we haven't written this one, so our answer will get wrong. How? So we are changing this j, but when we are changing this j to the absolute of j, so the j, if j is equal to -1, okay, if j has a negative, so the j in the matrix will not get changed if we haven't make the call by reference. Okay. Okay, now we will try to get the minimum element. So here we are finding out the minimum from them. Okay, after getting the modulo of yes, so absolute means we can say absolute means we are changing j is equal to modulo of j. Okay, sorry, absolute of j. Okay, this will be the, so it will change the j. If j is negative, so it will make it as a positive. Okay. So many of you know the absolute concept of the absolute, behind the absolute. Okay. So here we are finding out the minimum, and if after that, after the whole for loop runs, if we get the count modulo equal to modulo 2 equal is not equal to 0, so means it represent the odd. Okay. So we will answer minus equal to the minimum element into 2. Now how we will we are multiplying it by 2. Why? Because here we have done the absolute of j. Okay, here, so here we have added it. Okay, so answer, just take the answer. The one which will remain the negative, so we have already added it its absolute value to the answer. So now to neglect that absolute value, we are taking this multiply 2. Okay. So let's, so I guess that all of you understand the question and all of you understand the concept also behind our solution. So let's submit this solution. Yes, this is the 100% runtime appears, and its time complexity we can check by this. Okay, n into m. So what is the n here? That is the number of rows and number of columns. Bas. Okay, so If you haven't understand it, so comment below and I will be clearing your doubts. And thank you, and wait for the next lecture.